Our green waste compost is derived from urban materials, so it'd be grass clippings, leaves, tree trimmings, shrub prunings, that type of material. What's important about this stage of the material is that we inspect it and pull out any contamination, which is mainly things like plastic bags. It could be drink bottles, water bottles, those types of things. So if we pull those out now, then they don't get mixed into the material that we're grinding and trying to compost and then have to get out later. So Eugene, generally people are fairly conscientious, and so compared to other areas, I think we're fortunate that we have a pretty clean stream going into the process, which makes our job easier. So the material will vary seasonally. In the fall, for instance, we'll get a higher percentage of leaves, and in the spring we get a higher percentage of grass. Coming into the fall now, we'll get apples and windfall stuff from fruit trees that are in people's yards. So that all just becomes part of the mix, and we have to adjust our parameters a little bit based on what those feedstocks do seasonally. But generally, we're in a great area of the country to where our materials incoming are really pretty consistent, and they're relatively easy to compost. We don't have to do a lot of manipulations with them. So we just examined the incoming material. That's inspected. We pull out any thing that we don't want in there out. And then after that, it goes through a grinder and it just reduces the size. So that's what we see here. Inspected, ground, and now this is ready to go on our composting pad. After it's ground up, we bring it over here and we have, this is called an aerated static pile. So we have air pipes underneath the material that blow air up through it, and that keeps it aerobic. And aerobic composting is an important one. It's the most efficient way, it's faster, and it gives us a lot of process control. So we can keep the temperatures of the pile in a range that we want. So what's important for us to make sure we have a minimum temperature of 132 degrees for 3 days. That's what's called for an aerated static pile. And that way we make sure we kill pathogens. So a lot of people don't think about this, but in the green waste compost, because there's birds and pets and animals running around, we could have fecal coliform, we could have salmonella, we could have E. coli, which are all kind of big scary things. And we need to take those seriously and be concerned about that. So this process of time and temperature, 132 degrees for 3 days, is important, because then that means that we've heat treated the material to where it's safe. Doesn't mean it's done composting, but it's an important step in the process. And that's also a requirement for our organic certification. So this style of composting, this technique, really makes it easy to document and record keep for the documentation for pathogen control. Typically what we'll do is we'll put the pile on air, and this pile has been here for about 3 days, and we get up to temperature, we monitor it, and once we get to 132 degrees, we document that after the 3rd day. We'll keep this on the air for another 14 days is our residence time in this, and then we'll pull it off. We keep it on a little bit longer than it's required because the peak oxygen demand is at the beginning of the composting stage. So that kind of helps us get over the hump a little bit on that, and then we don't have to manage and turn it as much after it comes off of this process. It's not finished. It'll go into piles. We'll keep it another 3 months. We'll turn them periodically as needed. After it goes through a curing phase, we'll screen it, and we'll see that here in just a second. This is the end result of all the work that we've done previous to this. So we've sorted, we've ground, we've put it on air, we've cured it, we've screened it, and then this is really what we're after. So this is the final material, and it's nice, it's dark, it's rich, and this is the goal of this whole process. And the advantage to using compost is that it does add some nutrition. People sometimes think of it as a fertilizer, and it does add some nutrition to plants, but probably the biggest benefit of it is that it's the biology that comes with it. We have a lot of bacteria and fungi and actinomyces and all these organisms that are present in here, very, very active. And so when we introduce that into a soil or into the landscape, we start getting all these benefits because of the interactions that those microbes have with the soil. The bioassay is equivalent to the canary in the coal mine. A bioassay takes a plant and that's sensitive to certain compounds, and we grow that plant in this material, and we and a control, so we can compare as those grow. Do we have good germination? What's the vigor of the plant? Is it stunted? Does it look healthy? And so we are comparing a control that we know is a healthy plant with a plant that's grown in straight compost, which is usually not recommended. That's too concentrated many times, but it's a way for us to analyze and make sure that we don't have something going on in the material. When we're done with this should have a real earthy smell. It smells fresh, it smells like the forest, it smells nothing like the compost in the process, because there can be some kind of funky smells and weird stuff going on there, but that's just part of that process. Is those compounds are consumed by the biology, what we're left with is a sweet, earthy smelling material, which again, that is one of the indicators that tells us, okay, this material is well composted, it's ready to go. In potting soils, they all will have a lot of similar ingredients. You're going to have maybe some bark fines and pumice and perlite and core fiber and peat moss, and then fertilizer packages. So some potting soils will have some compost in them, a lot don't. And so that difference of having the compost in there, we think is very, very important because of what it can do for the soil and the plants, helps regulate the fertilizer. So it's a very important part. It's not a big percentage, but it's a very important component. And so this is the finished organic compost. That actually does smell really good.
It does.